Hello again, everyone. So for today, we will go deeper to the discussion of the different atomic models. Various models of atoms has been proposed over the years, and after the model was proposed, after some years, scientists would do experiments and disprove the model and will propose a new model. So just like in here, we have here John Dalton. His model is called solid sphere model. And then we have J.J. Thomson. His model is called plum pudding model. And then we have Ernest Rutherford. His model is called nuclear model. And then for Niels Bohr, his model is called planetary model. And last but not the least, E. Schrödinger or Erwin Schrödinger. His model is called quantum model. Okay, let's start. So let us have first John Dalton model. We have learned that John Dalton model is like a hard sphere or a solid sphere. It is indivisible, meaning you cannot be able to cut it. Sometimes they call it also as bowling ball model. Now, what is exactly the limitation of this model? Why it needs to be changed over the time? So one of the limitation is that since it was described as indivisible, meaning you cannot cut it, John Dalton failed to discover the subatomic particles. Next, we have J.J. Thomson, whose model is called plum pudding model. What is really the limitation of this model? So J.J. Thomson were able to discover the presence of the negatively charged particle, but he couldn't explain the results of Rutherford's gold foil experiment, which showed that atoms have a small dense, a positively charged nucleus. Okay, next, let us have Ernest Rutherford nuclear model. Now, let us learn the different drawbacks of Ernest Rutherford model. First, it could not explain the stability of the atom. According to Maxwell's electromagnetic theory, when electrons are revolving around the nucleus, because electrons are negatively charged particle, according to Maxwell's electromagnetic field theory, when a charged particle is under acceleration, it will give out energy. So are these electrons accelerating? When we say accelerating, that means acceleration. There's a change in velocity per elapsed time. So my question again is, are these electrons accelerating? Of course, the answer is yes, because even electrons are moving in a constant speed. They are moving in a circular motion. It is accelerating because as it moves in a circular motion, at every point of the circle, it will give you a different direction. So that means the direction is changing. So we can say that the velocity is also changing. Therefore, the electron is said to be accelerating. If the electrons are accelerating, according to Maxwell's electromagnetic theory, this means that they are going to radiate energy. So what does it mean? If it will give out energy, that means it will lose energy. If it continuously giving energy, it will slowly lose energy and it will collapse into the nucleus. And as a result, atom will not be stable. It could not explain the stability of the atom. We know that atoms are stable. Otherwise, we will not exist because we are made up of atoms. Next, Ernest Rutherford could not explain hydrogen spectrum. He failed to explain the specific spectral lines observed in the hydrogen emission spectrum. The hydrogen gas, when heated or under electric discharge, give this kind of line. So this is the one that he cannot explain why it happened. Next, we have Bohr's atomic model. So Niels Bohr proposed the Bohr model of the atom in 1915. It states that the negatively charged electrons orbit a small positively charged nucleus. We all know that the nucleus is the central part of the atom. So this red dots here represents electrons. It orbits around a positively charged nucleus. Some of the main characteristic of Bohr model is one, electrons orbit in the nucleus, like what I mentioned earlier, that have set size energy. So that means the energy of the orbit is related to its size. The lowest energy is found in the smallest orbit. That means if the electron is closer to the nucleus, the electron is in the ground state. What does it mean? It has low energy level. But electron will jump to the next orbit. That means it is now in the excited state or in the higher energy level, and then we will jump again to the next energy level. It is again in excited state, so that could be the highest energy level. Also, radiation is absorbed or emitted when electrons move from one orbit to another. Like from the ground state, it will go to the next energy level, it will be in excited state, and will go to the next level, again it will be in excited state, and then it will go back to the ground state.